Cleveland, even now I can remember, 'cause the Cuyahoga River goes smoking through my dreams.
The 1969 fire on the Cuyahoga River in Cleveland, Ohio, immortalized in Randy Newman's 1972 Burn On and REM's 1986 Cuyahoga, was not the first fire on the Cuyahoga River. It was, in fact, the 13th fire since 1868. According to the Cleveland Historical Society, up until the late 1960s, water pollution didn't trouble the residents of Cleveland. They saw it as a necessary consequence of the industry that brought prosperity to the city. The 1969 fire, barely noticed by the local media, caught the attention of Time magazine, but the photos published with the magazine were actually from a much larger 1952 fire. The publicity from the Time magazine article helped spur the already fledgling environmentalist movement in the United States, and in 1970, the U.S. Environmental Protection Agency was formed. The Clean Water Act was passed in 1972. The stated goal of the Clean Water Act is to restore and maintain chemical, physical, and biological integrity of our nation's waters. It called for zero discharge of pollutants into navigable waters by 1985. Despite 40 years of regulation, however, many of the nation's waters are still polluted. The Clean Water Act addressed the major issue of point source pollution, which occurs when an industry or municipality dumps pollutants directly into the water. The primary source of pollution in the 21st century is non-point source pollution. This pollution comes from agricultural and urban runoff, deposits of coal ash into surface waters from the air. Ash pond leakage, like we saw recently here in North Carolina, is point source pollution and is regulated under the Clean Water Act. And hydraulic fracturing, commonly known as fracking. Non-point source pollution often pollutes small streams and groundwater first, then makes its way into the larger navigable waterways, which are regulated by the Clean Water Act. The Clean Water Act does not regulate pollution of smaller, non-navigable waterways or groundwater. Groundwater is regulated by the Safe Drinking Water Act. General Chemistry 1 and 2 classes at Gaston College have been testing drinking water and surface water in Gaston and Lincoln counties for the past year. Students in these classes collect water samples which are then analyzed for several substances that give us a picture of the health of our local waterways and water supplies. Students analyze well and surface water for arsenic and lead. Due to the geology of the region, arsenic occurs naturally in some wells in our area. Just because it occurs naturally doesn't make it less toxic to those who drink the water. Lead is not found naturally in our local waters, so any lead found in well water or surface waters has come from industrial activity or lead plumbing fittings. Surface water is also analyzed for chloride ion, ammonia, nitrates, and nitrites. All of these are pollutants that may show up as the result of agricultural runoff, including from home yard chemicals. Ammonium ion, nitrates, and nitrites come from use of fertilizers and can speed up plant growth in rivers and lakes, causing overgrowth of algae and other aquatic plants, which reduce the amount of oxygen available to animal life in the water. Chloride ion concentrations usually peak in the winter or early spring as the result of runoff from road chemicals. Chloride ion in surface waters can have a negative impact upon aquatic life. Access to clean water is not just a concern for underdeveloped countries, it is essential for the continued health and prosperity of nations like the United States. Water testing is an essential tool to ensure that our water is safe to drink and can actually put out fires instead of catching on fire.